I was thinking about this, and when we hear the word explosion, um, our brains just instantly build this very specific, very familiar movie scene.
Oh, completely. It is a completely intuitive image for us to conjure up.
Yeah, like you picture a dark, quiet room, and then suddenly just bam, a bomb goes off. Shrapnel flies outward from this single central point, just tearing through the air and hitting the walls.
Right, because we are so used to things exploding in our everyday lives, or at least in movies. In that mental movie, there's a defined center where the event happened, and there is a pre-existing empty space that the debris is, rushing into.
Exactly.
It's violent, it's localized, and it makes perfect sense to our everyday experience.
Today, though, we are taking that exact mental movie and we are just completely tearing it apart. We're unpacking a really fascinating stack of sources for this deep dive.
We really are. We've got research papers, historical articles, cosmological data.
Yeah, and they all point to one staggering conclusion, which is that the Big Bang might be the most misunderstood idea in all of science. Because that image of the bomb in the dark room, that is what almost everyone pictures.
Almost everyone.
And almost every single part of that picture is completely wonderfully wrong.
It really is.
Yeah.
It is arguably the biggest branding problem in the history of physics, honestly.
For sure. So today's mission is about dismantling that massive misconception for you, our listener, and replacing it with something that is so much more awe-inspiring.
Absolutely. And by the end of this deep dive, you are going to understand why the annoying static on an old television set is actually literally a baby photo of the universe.
Which is so cool.
It is. And you'll also see why asking what happened before the Big Bang is fundamentally a geographically impossible question.
Okay, let's unpack this. Because if the Big Bang was not a giant explosion in an empty room, what was it? I mean, the name itself literally implies a giant, chaotic bang.
Right. Well, the name was actually coined as a joke by a scientist who didn't even believe the theory.
Wait, really? A joke?
Yeah, Fred Hoyle.
Yeah.
He was mocking it on a radio show, which perfectly explains why it is so misleading. The key to fixing this mental image is shifting from the word explosion to the word expansion.
Okay, expansion.
Yes. The Big Bang was not an explosion that happened in space. It was an expansion of space itself.
Wait, an expansion of space? So there wasn't like a dark, empty void just waiting to be filled with stars and planets?
Nope. And that is the hardest part to wrap your mind around.
Yeah.
There was no pre-existing void. And because it was space itself expanding, there was no single spot where a bomb went off.
Right.
There was no center to point to. It happened everywhere, all at once. Getting past that one hurdle that we are not dealing with cosmic shrapnel flying through an empty room, but rather the room itself stretching and growing that is the absolute foundation for understanding our universe.
I'm trying to visualize how scientists could even know that, though. Like, if there was no giant explosion and no central point, how did we even figure out the universe was moving at all?
That's a great question.
Because if it's just happening everywhere, how do you even measure that?
Well, to understand the mechanism behind that,
Mm-hmm.
we have to go back to the 1920s, to an astronomer named Edwin Hubble.
Ah, the telescope guy.
Exactly, same namesake. He was doing something that sounds quite simple on the surface. He was just measuring the light coming from distant galaxies. But when he analyzed the spectrum of that light, he found a really bizarre pattern.
What kind of pattern?
The light waves from nearly every galaxy out there were being stretched out.
Stretched out, like a rubber band. How can you even tell if light is stretched?
Think about the Doppler effect with sound.
Okay.
When an ambulance drives past you, the pitch of the siren sounds higher as it approaches you, and then it drops to a lower pitch as it drives away.
Oh, right, like a reow sound.
Exactly. Perfect sound effect.
Mm.
That happens because the sound waves are compressed as the ambulance moves towards you, and they get stretched out as it moves away. Well, light travels in waves too, and it does the exact same thing.
Okay, so instead of the pitch of a sound changing, the color of the light changes.
You've got it. When light waves are stretched out because an object is moving away from us, those waves shift toward the red end of the light spectrum.
And that's redshift, right?
Yes, we call it redshift. Hubble looked at these distant galaxies and saw that nearly all of them were redshifted, meaning they're moving away.
Mm-hmm.
And it actually gets stranger.
How so?
The more distant a galaxy is, the faster it is receding. So a galaxy 10 million light years away is moving incredibly fast, but a galaxy 20 million light years away is moving twice as fast.
Okay, let me pause and play devil's advocate here for a second, because I know exactly what you, the listener, might be thinking when you hear that.
Go for it.
If every single galaxy is running away from Earth, and the further away they are, the faster they are running, Doesn't that just imply we are the center of the universe?
It does sound like that.
Yeah, it sounds like we are sitting at the exact center of that bomb going off, and everything is just fleeing from our specific location.
It is the most natural, instinctual conclusion to draw from that data. And honestly, early astronomers wrestled with that exact thought. But it is incorrect.
Right.
And the reason why it is incorrect reviews the true nature of the expanding universe.
Well, our sources actually use a brilliant everyday analogy for this, and I want to lay it out because it helps so much. Imagine a lump of raisin bread dough.
Oh, I love this analogy.
It's so good. Just picture it sitting in a warm oven and it's starting to rise. As that dough expands, it puffs up in all directions. You have this solid volume of dough that is simply getting larger.
Right. Now let's look at the mechanics of that rising dough. Imagine you are a tiny observer sitting on just one of those raisins inside the bread.
Okay, I'm on a raisin.
As the bread bakes and the dough expands, what do you see from your raisin?
I mean, I'd see every single other raisin getting pushed further away from me.
Exactly. And let's think about the distances. If you look at a raisin that is 1 inch away from you, and the dough doubles in size, that raisin is now 2 inches away. It moved 1 inch.
Right, makes sense.
But if you look at a raisin that started 3 inches away, and the dough doubles, that raisin is now 6 inches away. It moved 3 inches in the exact same amount of time.
Oh, wow. So it looks like it is moving away from me 3 times as fast, just because there is literally more expanding dough between us.
That is the crucial insight. Space itself is the dough. The galaxies are the raisins. And here is the real paradigm shift. If you hopped over to a completely different raisin on the opposite side of the loaf, you would see the exact same illusion.
From any raisin.
Yes. From that second raisin's perspective, all the other raisins are rushing away, and the furthest ones are rushing away the fastest.
Which means no matter which raisin you sit on, it feels like you are the center of the expansion.
Yes, which mathematically means no single raisin is actually at the center. The whole mass of dough is just swelling uniformly. That is exactly what the galaxies are doing.
The space is stretching.
Yes. Space itself is stretching, carrying the galaxies apart. We are not watching stuff fly through empty space. We are watching space itself swell up and push the stuff apart.
That paints such a different picture. It's not objects moving through a void, it's the fabric between the objects expanding.
If we connect this to the bigger picture, once you grasp this reality that space is stretching out, an irresistible logical thought follows. You just run the film backwards.
Like hit rewind.
Exactly. If the cosmic dough is getting bigger as time goes forward, then yesterday, the dough was smaller.
So everything was closer together.
And 1 billion years ago, it was much closer still. If you wind that cosmic clock back far enough, you realize that everything in the universe, all the matter, all the energy, and all of space itself was squeezed together into an unimaginably hot, dense state.
Just to make sure we are being super precise here, it's all the space itself that was squeezed, right? Not just the matter squeezed into a tiny point sitting inside an empty room.
Right.
The entire room itself was squeezed down.
The entire room. And if you keep winding the clock backward, you reach a moment when that expansion first started, roughly 13.8 billion years ago.
Wow.
That initial stretching is the true Big Bang. It was the beginning of the expansion of everything, everywhere.
It is a stunning concept, but, science doesn't just accept a beautiful narrative because the math happens to work in reverse.
Definitely not.
A claim like the entire universe was once a microscopic, ultra-hot speck of expanding space that demands serious proof. We have to be able to find physical fingerprints of that event today.
Absolutely. A good scientific theory must make testable predictions. It has to say, if this wild idea is true, then we should be able to look at the universe right now and find something very specific.
Right.
The Big Bang Theory made incredibly precise predictions long before we even had the technology to verify them.
Let's talk about the first major piece of evidence, because it involves looking for the leftover heat from that primordial oven we were just talking about.
Think about the conditions of that early universe. If all matter and energy were squeezed into that microscopic, unimaginably hot state, it wouldn't have been dark.
Because of the heat?
Yeah. The early universe would have been filled with intense, blinding radiation, a uniform fireball of pure light and heat.
But if the universe has been expanding for 13.8 billion years, what happens to that light? It doesn't just burn out, right? I mean, energy can't just disappear.
It doesn't disappear, but it does change. Remember how Hubble saw that light waves from galaxies get stretched out by the expansion of space?
The redshift?
Yes. The exact same thing happens to this ancient light. As the very fabric of space stretched over billions of years, the light waves traveling through that space got stretched out along with it.
So a super tight, incredibly energetic light wave gets literally pulled apart into a longer wave.
Yes, and in physics, a longer light wave means a cooler, less energetic wave. The theory predicted that the blinding light of the primordial fireball would have stretched so much over 13.8 billion years that it would have cooled all the way down into faint microwaves. So the Big Bang theory boldly predicted that this cooled afterglow should still be arriving at Earth right now from every single direction in the sky, a constant, invisible whisper of radiation.
Here's where it gets really interesting. Making a mathematical prediction on a chalkboard is one thing. Finding a faint whisper of invisible microwaves from 13.8 billion years ago is another.
It is a tall order.
But they found it. And the story of how they found it in 1965 is honestly one of my favorite happy accidents in all of science.
It is the ultimate story of serendipity. We're talking about Arno Penzias and Robert Wilson at Bell Labs.
Right. They are working with this massive, ultra-sensitive radio antenna in New Jersey, and they're trying to bounce radio signals off balloon satellites, but they have this infuriating problem.
Focus.
Yes. No matter where they point this giant antenna in the sky, they are picking up this persistent background hiss, this static interference. They are desperate to get rid of it. They check all the wires. They think it's interference from New York City.
Didn't they even climb inside it?
Yeah. Yes. They climbed up into the antenna and actually scraped out years of pigeon droppings, thinking the heat from the bird mess was causing the static.
They systematically eliminated every possible earthly source for this noise. But the noise remained.
Because the noise wasn't coming from Earth. It was coming from everywhere in the sky, equally, day and night. What they had accidentally stumbled upon while literally trying to fix their radio equipment was the cosmic microwave background.
Incredible.
They had found the exact cooled afterglow that the Big Bang theory had predicted.
It is arguably the single most powerful piece of evidence we have for the origins of the universe. When astronomers study the cosmic microwave background, they are looking at a literal baby photo of the cosmos.
A baby photo.
Yeah, it is the oldest light in existence, released when the universe was only a few 100,000 years old.
And I want to make this super relatable for you listening, because this ancient light isn't just something that happens in billion-dollar observatories. If you are old enough to remember analog television sets, you know, the big boxy ones with the dials where you had to tune to a channel.
Oh yeah, I remember those.
You remember that if you turned the dial between channels, you'd get a screen full of black and white fuzz. Pure static.
The visual equivalent of the hiss those Bell Labs scientists heard on their antenna.
Yes. A small fraction of that fuzz on your childhood TV screen was literally that very radiation. Your TV antenna was picking up the cosmic microwave background.
That is just wild to think about.
You were watching the glow of the newborn universe leaking straight into your living room.
It's a wonderful reminder that the universe isn't just out there. We are sitting in the middle of its history.
So we've talked about the leftover heat and light from this primordial oven. But if the universe was truly that hot and dense, it wouldn't just leave a flash of light. It would have fundamentally forged the physical matter inside it.
Right, absolutely.
So does the physical stuff in the universe actually match what a 13.8 billion-year-old oven would bake?
That brings us to our second massive piece of evidence, which comes from a period physicists refer to as the first 3 minutes.
The first 3 minutes of existence? That is a tight window.
It is, but incredible things happen when temperatures are that extreme. In the very first fraction of a second after the expansion started, the universe was simply too hot for anything familiar to exist.
Too hot for atoms.
Exactly. It was so energetic, with everything smashing together so violently in this thermal chaos, that even the basic building blocks of atoms couldn't hold together. It was a plasma of subatomic particles.
So if you think of it like a cosmic kitchen, it is way, way too hot to bake anything. You throw your ingredients in the oven, but the heat is so intense that the ingredients just vaporize. Nothing can bind together.
That is a great way to picture it. But because space is expanding, the universe is rapidly cooling down.
Because it's spreading out.
Right. Within about 3 minutes, the temperature dropped, just enough. It was still incredibly hot, but it crossed a crucial threshold. It cooled enough that the strong nuclear force, the fundamental glue that holds the center of atoms together, could finally overcome that thermal chaos.
The oven cooled just enough for the simplest ingredients to actually stick together without instantly being melted apart.
Yes, protons and neutrons could finally grab onto each other, This process is called nucleosynthesis.
Okay, nucleosynthesis.
But here's the catch, and it is a brilliant piece of physics. Space was expanding so incredibly fast that this baking window only lasted a few minutes.
Oh, wow.
After that, the universe became too spread out and too cold for any more particles to crash together and fuse. The oven essentially turned off.
Wait, if everything is expanding and flying apart that violently, how did anything have time to fuse into heavier elements at all? Wouldn't the expansion just rip it all apart before complex fusion could happen?
That is exactly the limitation they faced. Because that window was so short, only the absolute lightest, simplest elements had time to form.
Ah, I see.
Physicists looked at this tight 3-minute window, balanced the dropping temperature against the rapid expansion of space, and calculated exactly what that original cosmic recipe should have been.
What did the math predict? What was baked in those 3 minutes?
The math dictated that the universe should have emerged from that window consisting of roughly 75% hydrogen, 25% helium, and a tiny microscopic trace of lithium.
Just hydrogen, helium, and a dash of lithium. What about everything else, like the carbon in our DNA, the oxygen we breathe, the iron in our blood?
The universe expanded too quickly for those complex fusion reactions to happen.
So where did they come from?
All of those heavier elements had to wait to be forged inside the intense, sustained heat of stars, which wouldn't form until millions of years later.
Okay, so the pure, original, uncorrupted recipe of the universe before stars polluted it with heavier stuff is just 75% hydrogen, 25% helium. Does the universe actually look like that today?
This is where the theory truly shines. When modern astronomers use telescopes to look at the oldest, most pristine clouds of gas in the deep cosmos gas that has been floating untouched and has never been processed inside a star.
Yeah.
That exact ratio is what they find. 75% hydrogen, 25% helium.
To predict a specific chemical ratio based on a 3-minute window from 13.8 billion years ago, and then actually find it, that is staggering.
For a scientific theory to get a prediction of that magnitude so precisely right is an astonishing triumph. We have the galaxies acting like raisins in the dough, proving the expansion.
Right.
We have the TV static afterglow filling the entire sky, proving the early heat.
Yeah.
And we have the exact 745 primordial recipe of elements, proving the physical conditions of those first few minutes.
It's just so airtight.
It all points to a hot, dense beginning that has been expanding and cooling ever since.
So what does this all mean? Because with all these telescopes and math proving the recipe and the afterglow, it is very easy to assume that the Big Bang Theory explains the actual creation of existence.
It is a common assumption.
Does the Big Bang Theory actually tell us what caused the universe or what happened before it started?
What's fascinating here is that we have to be incredibly honest about the limits of the theory. The Big Bang Theory describes the evolution of the universe from an instant after the expansion began. And it does that brilliantly.
Okay, after it began.
What it does not explain is what caused that expansion. And it certainly does not explain what, if anything, came before.
Which feels deeply frustrating. I mean, as humans, our brains are wired for cause and effect. We want to know who pushed the first domino.
It goes against all our intuition. But this requires one final paradigm shift. According to our best understanding of physics, especially general relativity, space and time themselves are not just an empty stage where the universe plays out.
They aren't.
No, space and time are part of the universe. They were created in the Big Bang.
Let's talk about the North Pole analogy from our sources, because this is where my brain starts to melt a little bit, but it makes so much sense.
It's the best way to visualize it.
Asking what happened before the Big Bang feels like it should have a logical answer. But if time itself started with the Big Bang, then the word before literally has no meaning.
Right.
It's like standing on the absolute geographic North Pole of the Earth and someone asks you to point north.
It is the perfect way to frame it. Take a moment to really picture that. If you are standing exactly on the North Pole, every single direction you look is south.
You can't point north because you've reached the absolute limit of where the concept of north even applies. The geometry of the Earth dictates that north simply ends right there under your boots.
Precisely. In the same way, asking what came before the beginning of time is a broken question. You've reached the boundary of the concept itself. The geometry of our universe dictates that time ends, or rather begins at that moment.
Does that mean physicists just throw their hands up and stop trying to figure it out?
Not at all. Theoretical physics is a wild frontier. Some scientists explore complex mathematical models, where our Big Bang is just one event inside a much larger, perhaps eternal, structure like a bubbling multiverse where big bangs are popping off constantly.
Wow, a bubbling
But we
multiverse.
have to be very clear. These are frontier speculations. They're not established science. Anyone claiming to know for certain what caused the Big Bang is venturing well beyond the evidence.
Got it.
The Big Bang Theory is a triumph because it is honest about its own edge.
It tells us exactly where our current understanding stops. So let's bring this all together. What is the big takeaway for you, listening right now?
The big picture.
First, the Big Bang was not a bomb in a dark room. It wasn't an explosion of matter into empty space. It was the beginning of the expansion of space itself, happening everywhere at once, 13.8 billion years ago.
Exactly.
And we know this because the universe left physical fingerprints. The galaxies are streaming apart, their light stretched out like raisins in rising dough. The ancient heat is still washing over us, hiding in old TV static. And the exact blend of hydrogen and helium cooked up in those rapid first 3 minutes is perfectly preserved in deep space.
When you step back and look at it, it really is one of the greatest achievements of the human intellect. Think about it. We are sitting here, tiny biological creatures on a small rock, 13.8 billion years later.
It's humbling.
And yet, using nothing but light waves, mathematics, and a profound curiosity, we can accurately reconstruct the first 3 minutes of existence from the inside.
It makes you feel incredibly small and incredibly significant at the exact same time.
And the fact that there's a profound mystery right at the very start, a question we may never have the tools to answer, that isn't a failure of science.
Yeah.
That is just the honest shape of the deepest truth we have been able to uncover.
I want to leave you with one final thought to ponder today, building on that idea of the edge of our understanding. We talked about how asking what came before the Big Bang is like asking what is north of the North Pole, because our concept of time started right there. But if our universe, our Big Bang, really is just one event in something much, much larger, well, could that larger something operate on completely different dimensions?
That is the big question.
Dimensions of reality and physics that the human brain, which evolved just to survive on this one rock, isn't even equipped to imagine. So the next time you picture that cinematic explosion in a dark room, let that image fade away. Replace it with the universe expanding, stretching, and cooling. And remember, the real story is so much bigger than a bomb.